Thank you so much for coming. It's really nice to be here. I'm Rebecca Fiebrink. I'm a professor of creative computing, and I've been building machine learning tools for creators for almost 20 years now. I think it's fair to say that many of us in the room are curious about what AI can really do for creativity, how we can use it in ways that feel valuable and authentic and exciting, even when maybe that doesn't line up perfectly with the vision for AI that we're being sold by big tech companies. And many of us also really care about developing meaningful critiques of AI, making responsible choices about how we use it, and contributing to current conversations and debates about its use and regulation and so on. All right, so if we want to appropriate AI for our own creative purposes, or we want to reason about it effectively, a really good starting point is to look at the foundation on which these systems are built, and that's data, right? Most of the time, machine learning data is treated as something fixed and objective and true. But in creative practice, data can be something very different. It can be dynamic and contingent and messy and a mechanism for communication and negotiation between people and machines. So thinking about data this way opens up some really exciting creative possibilities, and it gives us a new lens for critique. So in this talk, I'm going to share some of my very favorite creative works, creative projects that approach data in this way. These projects treat it as a material for expression and negotiation rather than as a static truth. My hope is that you'll leave with some new ideas about how AI could be more personal and participatory and reflective, and have some new ways to question the AI systems that dominate the headlines right now. All right, so let me start out by introducing the conventional view of data in machine learning. Notice that I'm saying machine learning here and not AI because it's a more precise term. It also avoids some of the hype and baggage of AI. So if I were writing a standard machine learning textbook, I might start with an example like this one. Imagine we want to predict maybe which medical treatments might work for new patients. We can start by collecting data from a whole bunch of patients, right? Demographic information, test results, as well as data about whether they respond to a given treatment or not. And we can use this to build a machine learning model that predicts whether a new patient will respond to that treatment, right? Or of course, maybe I want to generate realistic sequences of words in English or some other language. And I might start by grabbing huge collections of text from the internet and use a machine learning model to capture the relationships between words in the text. And machine learning can be really powerful in these contexts because it's capable of capturing and modeling patterns in these data sets that humans don't fully understand, right? I don't know why some medical treatments work better than others. And I can't write a formula for how to produce convincing English text about an arbitrary topic, even though I'm a native English speaker. But machine learning models could potentially use these data sets to learn these kinds of patterns. So here we talk about the training data in this conventional view as ground truth. It represents something true about the world. And having a good model provides a means to engage with that truth when we couldn't otherwise. So if we think about data in this way, we arrive at some fairly well-known unconventional implications. More data is better. More complex models are better. Because if we have contemporary deep learning techniques that are very data hungry, those models can capture complex relationships, like the relationships between words in English, more accurately. Also, we want data to be representative of the real world, right? We want patients of different demographic backgrounds and medical profiles, text written about many different topics. If we're doing song generation, we want songs of many genres, and so on. And so this is illustrated somewhat ironically, of course, with a stable diffusion image of a person worshiping at the altar of big data. And I feel like we've all been led to this altar and told, all right, this is the altar that we are stuck with. And of course, another implication of this conventional view is that bias in data sets is bad. Bias can look like over or underrepresentation of some types of data, right? If we delete most of our women from our training set, we're not going to have a model that necessarily performs well on women in the future, right? That's a bad thing. Also, data might represent problematic patterns or biases in the real world, and models trained on those data sets might perpetuate or amplify them, right? We've seen this over and over again with generative models, where if we were to, say, type in lawyer to a system, we might get images of old white men. And when we type in flight attendant, we get images of very stereotypically feminine, young East Asian women, right? These are problems. These are real problems. I don't want to minimize that. But what if data is not the truth? What if machine learning actually isn't just a tool for engaging with true patterns in the world? And I would argue that a lot of creative machine learning actually looks more like this, right? We're using machine learning to uncover, not to uncover some truth in a data set, but we might be making a thing to interact with. Or we might be engaging with materials in new ways, or telling a story, or exploring some new aesthetic possibilities. This is a really big departure from the assumptions of conventional machine learning. And this is pretty interesting. So what is data doing if it's not the truth? I'm going to spend the rest of my talk exploring this question. And I'll use my own work as well as examples from some of my favorite artists to illustrate the new practices and tools and understandings that become possible when we stop pretending that the data we use has to be true. I'll break this down into a few different observations that I've found really valuable in my work and my teaching. Each of these observations I'll share was something I really discovered the hard way. I was trained in machine learning as a computer scientist, and really it was through many years of collaboration with creative colleagues, with students, that I've learned how to understand data really differently than the way I was taught about it. All right, so let's jump in. The first unconventional observation I want to share is this. In creative machine learning, training data might not be ground truth at all, but rather a way for people to communicate ideas and intentions to machines. This is an understanding of data I stumbled into about 17 years ago now when I started building a software tool called the Wekinator. I was really interested at that time in exploring this question of, how could we use machine learning to build new types of real-time interactions? I was coming from a background in music. I was interested in building new digital instruments where sensors might capture information about how performers are moving and then translate that into control over real-time digital sound. But there are really other similar problems that appear in music and other domains too. I was interested in live music analysis, where properties of music being played might be used to control visuals or lighting or other phenomena. And of course, this is similar to challenges that we encounter building interactive art projects or embodied games, where the actions of a person might trigger events in a game or a virtual world. Now, all of these types of systems can be a good match for a type of machine learning called supervised learning. And this allows us to teach the computer how to respond to some action made by a human. So for instance, if I'm building a new musical instrument that's controlled with hand gestures, I could train a supervised learning algorithm on a data set that consists of some hand gestures, and each gesture is paired with the sound that I want my instrument to play when I make that gesture. Right? I can go through a training process, and that builds me a model. Models are the predictive bit that's produced by machine learning training. And that model can, if everything goes well, look at a new hand gesture and produce an appropriate sound. Now, when I started this work in 2008, there really weren't tools out there that creators could use to use this process in their work, especially if they were working in real-time domains. So I built the Wekinator to try to make this easier and to see what would happen. And one of the first things I learned is that it wasn't enough to just put a really friendly user interface on top of these algorithms and data, right? There was something fundamentally different about what creators needed to do. For one thing, if you want to build a model like this, the first thing you need is a suitable training set, right? You need these examples of gestures and sounds. So the first thing that Wekinator allows you to do when you open the program is to demonstrate that training set, to build it in real time, showing it new gestures and sounds. And once you've built your model, you need a way to figure out if it's any good, if you want to use it in performance, or if you want to change it somehow. And so Wekinator also allows you to test out that model in real time with new data, right? Showing it new gestures and seeing how it reacts. Finally, the third kind of weird thing that Wekinator does, it allows you to go back to the training set. This is totally not allowed in conventional machine learning contexts, and for good reason, but here it makes sense. If you say, you know what, my model's making mistakes on a particular type of gesture, I want to give it more examples of the thing it's getting wrong, and I maybe have a reasonable hope that it will improve the model when I retrain. Or maybe I want the model to be more complicated. I have an idea for a new sound I want to put into my instrument, and I can go back to the training set and do that. So with that, I'm going to do a quick demo for people who haven't seen this before. I'm going to run Wekinator, and I'm going to run still my favorite demo after a long time. I call this the world's worst computer vision program. It's just taking my webcam and chopping it into 100 pixel blobs, and actually converting this to grayscale, I think, too, before using it to classify. But we're gonna build something from it. And I'm gonna build one classifier, and this classifier is going to control a drum machine. So I'm gonna turn this down a little bit so I can talk over it, and you can still hear me. I don't have a data set for this yet. Ooh, I also don't have data that oh, I set it up wrong. That's okay. We're gonna start over because this is easy. I'm gonna tell Wekinator to listen for these 100 values and then make me a classifier. All right, so I'm going to give it a training data set from scratch. I'm gonna say, hey, when I stand here in front of my camera, wearing these clothes on this stage, I want to hear this sound. So I'll give it, oh look, 11 examples. Let's start with that. And now I'm gonna give it examples of me not standing here. And now I've got 40 examples total. Let's see what happens. We're gonna build a model from those examples and try it out. Okay. It's working pretty well. Let's see if I can get it to make a mistake. Okay, it's making a mistake right here, so I'm gonna go back and give it more examples of the thing it got wrong. And I'm gonna retrain it and rerun it. And now it's doing that right. And it's still doing that right. And now I can say, hey, this is cool. Maybe I add another sound to it. And this is my hand in front of the camera. So there's me with no hand. There's my hand, right? So I've done all of this with 77 examples, right? Tiny training set with bad data. And I've built something that still works, which is kind of cool. So we're going to talk about that. All right. So Wekinator has been used by tens of thousands of people now in all sorts of wonderful and crazy creative projects. These include ones on screen here, musical instruments that sense people's gesture in really new and creative ways. Here's Letitia Tsunami with a spring spire, which is a bunch of metal she found in a junkyard with strings and audio pickups on it. This is Michelle Nagai's martlet, which is a piece of tree bark with light sensors in it. People have used game controllers, all sorts of other things. I had a student make a snake-controlled musical instrument. People have made interactive art pieces like this one, which turns your glasses blurry if there's a screen in your field of view, so you can't look at your phone while wearing this art piece. There's cute projects like this one. This is Highbot, which just waves back to you if you wave hello. Let's see Highbot here. There's Highbot. Totally cute, right? I want a Highbot. Okay. Other Wekinator projects range from high-fashion interactive footwear to digital puppetry to one project I saw online where somebody uses food to control Google Maps. You hold up a croissant, it takes you to Paris, and an espresso, and it takes you to Milan, right? All sorts of fun things. And this really took off, and this type of interaction with machine learning was, I think, successful and useful enough that we ended up exploring it in a bunch of other projects as well. You may have come across some of these. So we've got tools in C++ and JavaScript. We've got an online platform called Mimic, which is JavaScript-based, and we use that in teaching. I have a project with, that I'll talk about a little bit later, called Sound Control, building musical instruments with kids with disabilities. And we've got a Unity Unreal program called InteractML. All right. So in all of these examples, all the creative projects I showed you, we can think about data as a powerful way for a designer to communicate to the machine. It's through the choice of training examples that the person building the system specifies, what are my creative objectives? What do I want the computer to do? What kinds of patterns are allowable, relevant, and useful? And if I'm not satisfied with the model, what do I want the model to do differently? How do I want it to change? Of course, as you saw in the demo, the data isn't static. The data can change throughout my design process. So this understanding of data as a vehicle for communicating a designer's intention, it's not just relevant for supervised learning approaches like Wekinator does. You can also see it in many projects that use generative AI. The first one I'll show you is by the artist Memo Atkin. He's been doing some really lovely creative work with generative machine learning for many years now. This is an example of a project from 2019, which is like 100 years ago in machine learning years. This is, I think, the first real-time image-to-image generation piece that I know of. And what he's doing here, you'll see on the left, is the input to his webcam. And on the right, he's got a machine learning model that's transforming that into a very different type of image. Now, this is a pix-to-pix model, and this model has only been trained on seascapes. And so he, no matter what image he gives it from the webcam, it's trying to reconstruct that using the only data that it knows, and that's seascapes. All right? So this is quite beautiful, and he's manipulating objects in his webcam in real time to manipulate the video here. And then a different model he builds was only trained on fire. And so he turns anything he shows the camera into flames. And this one, of course, is flowers. I think this is still a really lovely piece, and Memo talks about it in this paper here as a sort of visual instrument that can be performed and experienced in a live, embodied way. All right, Anna Ridler, who many of you probably know, she's another artist doing work with machine learning, and I really love all of her work. Another early piece that she made with generative models was based on the old black and white film, Fall of the House of Usher, which was in turn based on an Edgar Allan Poe short story. And what she did was, I think, really lovely and fun. She took some frames from the beginning of this film, and she rendered them herself by hand sketching them. And then she trained the same type of model that Memo did, a pix-to-pix model. She trained the model to look at an arbitrary frame from the film and kind of reproduce it in her own style. She's got this great blog post about the piece, and she's very explicit that the creative control that she has in this process, she says, it really comes from what I do with the data set. Right? It's not about, oh, I can add another layer to my neural network, or I'm going to change the optimization method in this way. No, it's really about the data set that she creates as an artist making the sketches. So we think about data as a way for people to communicate ideas and intentions. This helps us understand how personal and bespoke data can be a powerful way to use, to make useful models. Sometimes, in fact, small bespoke data sets can be much more powerful than big data. And we saw this already in the examples of Anna Ridler's work and some of the unique interactions made with Wekinator. But I want to mention another few projects that make great use of small data sets. The first one is called RVAE. This is by my former postdoc, Gabriele Vigliansoni. He's a musician who wanted to use generative models to make not passable pop music like you can make with Suno or Udio. He wasn't really interested in that kind of thing. He was interested in using generative models to make his own music, to make music that he could play with live on stage that would still sound like him. So his RVAE project allows you to train a set of generative models on a very small data set of rhythms, the kinds of rhythms that he uses as a sort of experimental dance musician. And these data sets can be as small as just a few dozen examples. The models that this makes can then generate rhythmic variations of the examples in real time. Each model gives you a pretty narrow set of musical possibilities, but just like with Wekinator, you can train lots of different models to do different things, maybe to use in different sections of a live performance. Also, RVAE models the rhythmic patterns themselves. It doesn't model the whole audio waveform, it just models when onsets happen, right? So this is a simpler problem, and it needs a lot less data. It also gives you a nice real-time interface, and you can move the mouse around and explore the latent space of the model in real time, so it becomes a nice performance interface. So I'll give you a quick video of this. It is a little bit flashing lights heavy, so if that's something that bothers you, don't look at the screen for the next 10 seconds. All right, I want to give one more example to illustrate the power of small data. Stephanie Dinkins is another fantastic artist who's been working with AI for a long time now. This is her piece called Not the Only One. She describes this work as an attempt to create a multi-generational memoir of a Black American family told from the perspective of an AI of evolving intellect. She uses a machine learning system that she trained on oral histories from 3 generations of her family. And she embedded this in a sculpture that you can walk up to and talk to about these histories. Here's a little video of this piece.
Yes, it's the holiday shopping.
What kind of shopping did you do?
Yes, the most of the memories.
What kind of memories?
Here's just the scrapbooks.
What? Where are the scrapbooks? I'm so intrigued. I want to know more.
All right. So both of these works, I think, illustrate some of the advantages that come with training on small data, right? Simpler models that are trained on small data can make it easier to get the outputs you actually want if you're a creator and you have a particular creative vision. Training small models on small data sets is fast, it's easy, it's cheap, it's environmentally gentle. Because it's so fast and cheap, we can train multiple models to do different things, and we can retrain to adjust and improve models. Simpler models can run more easily in real time, often on things like Raspberry Pi now, which is pretty nice. And also, I didn't say much about this, but when we use big foundation models or other commercially available models that are supposed to be general purpose, actually what we find is they're really good at modeling the kind of stuff that appears a lot on the internet, and they can be less good at modeling more niche phenomenon, right? Niche musical genres, or maybe stories about particular kinds of people and experiences. So this leads me to my next point. Bias in data isn't always bad, right? Data is always the result of human choices, and we, as creators of data or machine learning systems, can choose to prioritize certain characteristics rather than pursuing some notion of generality, which I would say isn't even possible at all. None of the example works I've shown you have used models that try to be general purpose in any sense, right? They do just one thing, and to accomplish this, they've been trained on data that's really carefully chosen to represent that one thing, right? So the instruments built with Wekinator, people have said, these are the gestures, these are the sounds that I care about. Or Gabriel has said, these are the rhythms I care about. Dinkins has chosen whose stories are represented, and Memo's chosen which visual worlds he cares about. All right, so this leads me to my next observation, which is that data and machine learning can actually be better than math and code for communicating tacit knowledge and embodied practices to computers, right? This is a perspective that kind of broke my brain when I figured it out while building Wekinator, right? If we think about data as a way of communicating our intentions to a machine, doing this with data captured from our own demonstrations can actually be an effective and a natural way of communicating about anything that entails tacit knowledge or embodied practices, right? So this is true with people as well. This is not specific to machines. If you were an alien from another planet and you came to Earth and said, hey, Rebecca, what's a wave? I wouldn't give you the mathematical equation for how, the fingers of my hand and my palm move over space and time, right? I would say, here's a wave, right? And if I wanted to be really thorough, I might show you different kinds of waves and say, these are all these are all waves, right? I would do that to another person as well. And of course, this happens all over in creative practice. We might care about how we want something to look or sound, how we want to move or act as somebody interacting with the computer. These are so central to a lot of the creative projects that I think about, that my students think about. And machine learning gives us a really great interface to do these things, right? We don't have to use math or code or even natural language. We can use demonstrations. And as somebody who learned about machine learning as a computer scientist first, I really, again, just came to understand this through collaborations with musicians and artists using my tools. I would interview early users of Wekinator and ask them, what they found useful about it, and they never mentioned things like, oh, it was really accurate, or it was really efficient. They didn't even talk about it making their practices more efficient, right? That's just out the window in so much creative practice. What I did get back from them were things like this quote from a musician saying, "I've never before been able to work with a musical interface that allowed me to really feel the music as I was playing it and developing it. The Wekinator allowed me to approach composing with electronics in the computer more in the way I might if I was writing a piece for cello, where I would actually sit down with a cello and try things out." Of course, I don't think anything could have been farther from the minds of the computer scientists developing the machine learning algorithms we were using, but there we were, finding that machine learning offered this sort of embodied intimacy that creators working with digital technology had been wanting. And this recognition of how machine learning can support embodied interaction really inspired another stream of research that my collaborators and I have been working on. These are some examples from the InteractML project and some artists who've used it. This allows people who are doing interactive art in VR to build new interactions by demonstration. And so people have made like a semaphore communication system. Another artist, Busha Burge, made a really cool dance piece in which a VR environment responds to a dancer's ankle movements. So this is another nice set of tools that I'm really proud of contributing to. Next, I want to talk about how designing with data can enable more people to become creators. And I think to an extent, this is part of the story that we're getting about AI and why AI creativity is exciting. But a lot of the tools out there that get a lot of attention are really these sort of one-size-fits-all general purpose models that, they're making it easy for novices to conform to a standard, right? Anybody can make a painting like a French impressionist, or, make a movie trailer that looks like Wes Anderson or something. And there's nothing wrong with that, right? Some of these tools are useful, commercially viable, they're fun, but it's not, for me, getting to the heart of what it means to be creative. A project that I mentioned briefly earlier, sound control, was something that was inspired by Wekinator. I was approached by a music teacher and a music therapist who said, hey, we see what you're doing with Wekinator, and we work with primarily kids with a really wide variety of disabilities. Do you think we could use something like that to make new musical interactions and new instruments for those kids? And so a couple research assistants and I built something that was very much like Wekinator, but sort of a streamlined interface that was customizable in different ways that the teachers wanted. And it was super cool, right? It was super cool in one way because it did allow them to build musical interactions, and that was great. But the best thing for me that came out of it was that the things that these teachers did with the kids were totally not what they wanted to do when they came to me and told me what they wanted, right? And they weren't what I would have designed for them if I'd been sitting in the room just taking down specs, or if they'd had another engineer in the room with them, right? As soon as we put the technology in their hands and they could explore it with the kids, they started doing things that they had never thought about before. They were making games. They were making sort of improvisation systems that went really beyond what they thought of as instruments. They also made a lot of fart noise controllers, because it turns out that kids love fart noises, and we had to put a whole sample library of fart noises in so that they could manipulate them in real time, right? So I really like this project because, again, it shows that when people have the ability to interact with machine learning, build machine learning systems for themselves, for their communities, that's when a lot of true creativity and true value happens. The last observation I want to share with you today is about how the interplay of building machine learning models from our own data can challenge and change us, and even change how we understand ourselves. My first introduction to this perspective came from one of the early users of Wekinator. This is Meg Shadell, who's a composer and cellist, and she used Wekinator to build a series of bow gesture classifiers. And one day when she was working with the system, she kept running into problems. She wanted to build a classifier that could tell ricochet and spiccato bow strokes apart from each other, and it was failing. And finally, she realized that she was just tired, and she had become really sloppy with her technique. And as soon as she, had a coffee, rethought about it, sat back down, she was able to make a classifier that worked well. Oops, not the right button. Okay, I saw many other examples of this phenomenon in a recent project that I did with colleagues at University of the Arts London. This project is called Transforming Collections, and it was led by the UAL Decolonizing Art Institute. And my colleagues and I were exploring how machine learning can be useful to art historians, curators, and archivists who are working to uncover bias in collections and make new kinds of connections between artists and artworks. And so we built some machine learning tools for users to build classifiers or labelers for their own concepts and for their own collections. For instance, we had one person on the project who wanted to know, can I build a classifier that finds whether art jargon terms are used in text and not explained, because that makes something a little bit less accessible. Or we have a bunch of text descriptions of artworks. Can we find descriptions that prioritize the artist's racial or other identity over formal qualities of their work? And we built some user interfaces, like the one on screen, right? Not super exciting, but functional. These interfaces allowed people to take texts that were of interest to them, and also images, and they could build their own classifiers for them. This used an interactive machine learning workflow really similar to Wekinator, where they would label some stuff, see how the model did when trained on those labels, and then iteratively improve the model by adding more labels. Just like Meg, the cellist, sometimes the classifier came up with results that they didn't expect. And sometimes this led people to pause and consider whether maybe the classifier was right and they were wrong, or whether they needed instead to supply better training examples to convey their ideas better. But even more interestingly, this process of labeling the text itself sometimes was really challenging and sometimes prompted deep reflection and changes to people's goals. And people even describe this process of interactively selecting and labeling examples as facilitating a sort of close reading of their data that they hadn't engaged in before. They had to critically examine not just the material that they were labeling, but also the labeling concept itself, to say, hey, what is it to mean that some text about art uses specialized language? Or what is it to talk about racial identity? What is it to talk about, as another example, I think someone was interested in making claims that were unsubstantiated, right? People started really questioning their own concepts, which they had come to the process thinking were well understood, and then realized that they needed to do more work. And of course, a lot of this labeling happened in social contexts, right? People working with their colleagues, for instance, and we saw these labeling systems as really catalyzing collective grappling with the meanings of, hey, what are these texts that we're working with, and what do we really want out of this process? All right, I'm gonna skip this. Finally, generative machine learning trained on one's own data can also have this power to instigate self-reflection. In Anna Ridler's blog post on Fall of the House of Usher, she writes, "This idea of control is misleading. It's impossible to predict what will come out. I can guess, but I cannot know. The errors and choices that are made when I'm drawing are amplified, and the GAN holds a mirror up to my own drawing and makes me realize things that I was not aware of. What I find the most important, what I always edit out. It is my work, but also not my work. Recognizably me, but nothing I would have been able to do by myself. Watching it is a very odd sensation, like catching a glimpse of yourself in a mirror before you realize it is you." All right. So I've talked about the following observations here today. Training data can be an interface through which people communicate with computers. People communicate about their creative objectives, about what they want the computer to do, about what patterns are in scope. Small, personal, and bespoke data can communicate these things really powerfully. Bias in data isn't always bad. Data can communicate tacit knowledge and embodied practices. It can enable more people to become creators. And building models with our own data can be a process that challenges and changes us. This understanding of data has some far-reaching implications for creative work. Here are some of the things I teach my creative computing students at UAL who are using machine learning. Number one, treat data in machine learning as a creative material, right? Just like clay or paper or text, you can shape it, remix it, evolve as you go. Don't forget to explore small models built on small data sets, right? Sometimes big models aren't necessary, and sometimes they're even counterproductive if they don't match the thing that you actually want to do. Embrace unsexy algorithms, right? Things like shallow neural nets, k-nearest neighbor, stuff out of the 20th century. If you have small data, sometimes these can work better than the newest, shiniest deep learning method. And for the folks in the room who have some machine learning knowledge, you've probably been taught to avoid overfitting at all costs. Actually, that's unnecessary and even counterproductive in some creative scenarios where you have data that's maybe very carefully curated and you want it to be, fit. Finally, if we understand data as something that we design or choose, something that represents our expertise or creative vision, our embodied experience, our culture, then cultivating and sharing data can be practices that have real value to others. So we can explore how we might do this, maybe imagine what better community-driven data sharing infrastructures might look like. And this is the subject of some of our upcoming and recent work at UAL. And finally, it should be obvious now that a model's training data always encodes choices, whether we're talking about an art project or a massive commercial generative model. So no data set or model is a technologically determined inevitability. Someone somewhere has made choices about who should be able to use this model and to do what. How should model complexity be balanced with other considerations like environmental impact, intellectual property, how much data is needed, and so on. And the data sets that are used are going to reflect people's choices, real choices about what is worth modeling and what is not. So we've reached the end of my talk, and I'm going to leave you with some final questions. If data is a dialogue, a means for communicating with machines, who's doing the talking right now, and who's not? Who's being silenced? What kinds of data conversations would you want to have with a machine? I'm not talking about ChatGPT, I'm talking about, if you could communicate your embodied practices, your tacit knowledge, your visions for the future, your visions for how to interact with computers and the people around you, what would you want a computer to learn from you? What might it look like to build data sets and models that embody principles of care, creativity, human dignity, a value for diversity, or other things that you care about? And what models could you imagine, big or small, that reflect the future that you want? So that's the end of my talk. Thank you so much.